Good morning, students. Here's my golden doodle Schroeder, and here's my black lab Frank. All right, there are guest students today. They're going to be listening in on the lesson on translations. Okay, these dogs find geometric transformations very interesting. They'd rather do this than go to the pond and swim and chase ducks and fetch sticks. All right, so translations. All right, so essentially what we're going to be talking about is sliding. All right, these are slides. And we can think of addition and subtraction. All right, this is what this really boils down to. Okay, so coordinate notation looks like this: x, y arrow, x plus a, y plus b. All right, that means that if a point in the pre-image, all right, so pre-image, you might think of the pre-image as like, we could call it point z, is given by the coordinates x, y, then the corresponding image, that would be z prime, would be shifted a units horizontally and b units vertically. All right, so let's just dive into this, all right? Here's an example from the 2009 OGT. Translate the figure 3 units to the left and 5 units up. All right, so what we got to do is we got to take the English language, 3 units left. Remember, A is your horizontal, so 3 units to the left is going to be x minus 3. And then we have 5 units up, so that's my horizontal shift, plus 5, okay? And what does that mean? Well, let's just start doing this on a coordinate plane and really just get the gist of it that way. All right, so point S is at negative 1, 2. That means I'm going to go 3 to the left, 1, 2, 3, and 5 up. 1, 2, 3, 4, 5. Boom. And that's S prime. What are the coordinates? Negative 4, 7. And what's interesting is technically I can figure out the coordinates without even looking at the graph. How? S is negative 1. If I'm going 3 to the left, it's 1 minus 3, so negative 4. Or I have 2, and I go 5 units up, 7. All right, so that's how coordinate notation works. All right, and let's just keep cruising right along. Now I got T is at 3, 1. So let's do this with addition and subtraction and see if I can land at the right spot. So negative, or 3 minus 3, so it's going to be 0. And then 1 plus 5, it's going to be 6. So let's see, I'm going to plot 0, 6, which would be boom, right there, T prime. And let's see how good of a job I did. 1, 2, 3, 1, 2, 3, 4, 5, boom, freaking sweet. All right, and let's pick this color next, why not? All right, and let's just continue to count on the graph. That's probably what I prefer to do. 1, 2, 3, 1, 2, 3, 4, 5. That's going to be U prime at negative 2, 1. And then lastly, R is going to be 1, 2, 3, 1, 2, 3, 4, 5. And R was at negative 4, negative 5, and now it's at negative 7, 0. If you guys listen closely, you probably can hear the train in the background. You might have even heard my golden doodle getting a drink of water. It's a busy morning at 5:27 a.m. Lots to do. I was so excited to do this lesson I couldn't sleep. Neither could my dogs. And that's it. Pretty cool, huh? All right, and what we could also do, just to prove that these images are congruent, this is gonna look us a little sloppy because I got a lot going on. Actually, let me do it like this. I got a good idea. All right, I'm not gonna trace it. I'm gonna trace it the best I can. Then, watch this. Boom, see how I can slide it right on top? All the side links are the same, all the angle measures are preserved. So just a little quick refresher, remember, this is a quadrilateral. I could say STUR is congruent to S prime, T prime, U prime, R prime. Side, length, angles, angle. There's my golden doodle drinking again, if you listen closely. measures. These are all congruent. Alright, so that's it. It's basic addition, subtraction. That's the big punchlines of translations themselves. We just performed a translation. Now we're just going to do a series of problems. We're going to think about things, so on and so forth. Point A, the pre-image has coordinates 6, -1. If the coordinates of A prime, the image, are -2, 2, describe the translation that occurred. Alright, so basically you've got to think, what do I have to do to get from 6 to -2? And remember, the punchline of this is addition, subtraction. It's -8. What do I have to do to get from -1 to 2? Well, I have to plus 3. So there's several ways to do this. It's good to know all ways. You can do it in the English language. You can say left 8, up 3. Or coordinate notation, which coordinate notation is very important. This is the way you talk to computers. X minus 8, y plus 3. Alright, now I'm going to tell you right now, this is good. This is full credit. This is the best way to do it. Bad, I see students do this, is go -8 plus 3. Although we know what you mean, this is not perfect. You have to put x minus 8, y minus 3. So this is bad. Don't do it like this. Make sure you include the x. Make sure you include the y. Alright? Next, the transformation xy arrow x plus 4y minus 1 maps t onto t prime. The transformation xy arrow x minus 7 y plus 3 maps t prime onto t double prime. Write the coordinate notation for the translation that maps t onto t double prime. So right now what we got going on is a double translation. So we go from t to t prime. How? X, y, arrow, x plus 4, y minus 1. Next we go from t prime to t double prime. How? Translation again. X, y, arrow, x minus 7, y plus 3. Alright, so the first time I'm moving 4 right, and then the second time I'm moving 7 left. And the first one I'm moving down 1, and then the second one I'm moving up 3. So, how do I combine this into a single move? I want to go directly from t to t double prime. X, y, arrow. I'm just going to bash them together. X plus 4 minus 7, comma, y minus 1 plus 3. Alright, I'm bashing them together. So the single translation would go x minus 3, y plus 2. And that's the answer, ladies and gentlemen. Alright, so instead of going 4 to the right and then 7 to the left, I can just go -3 immediately. Instead of going 1 to the left and then 3 to the right, I can just go 2 to the right immediately. Okay? So let's knock out this next page and then we'll call it a video. Ali and Tyrone are discussing the transformations in the drawing. Who is correct? Alright, Ali said this is a translation, right 3 units and down 2 units. Alright, Tyrone saying that this is a reflection across the y-axis and the x-axis. Alright, so reflecting, we had minimal stuff about reflecting, but let's talk about this. If it's reflecting over the x-axis or the y-axis, that's the mirror, or excuse me, that's the mirror here. Well, it's going to be somewhere over there. So we already know it's wrong because then I reflect over the x-axis and it goes there. Alright, so Tyrone is wrong. But that's not really what I want to talk about. I wanted to talk about Ali being right. Why? Alright, this is a translation, 3, or right 3 units. So let's count. 1, 2, 3, and now 2. 1, 2. Alright, so Ali's the one who's right. Check. Alright, I just wanted to do this problem to show how we can take translations into words, apply them to a coordinate plane, and show how it works. Alright, So if a translation, now we're on number 4, if a translation maps the point -8, 12 onto the point 5, -4, then according to that same translation, what will the image of 7, 8 be? Alright, so let's just focus on this stuff right here. This point to that point. Well, what's exactly going on? Alright, well, to get from -8 to 5, you got to add 13. To get from 12 to -4, you got to subtract 16. So this is the translation that's occurring in coordinate notation. All right. That's it. So basically I'm going to take this point 7, 8 and plug it into this. So that means I'm going to do plus 13 minus 16. So the new point will be 20 minus 8. And that, ladies and gentlemen, is the answer. All right. So a couple more. Explain in words what the following transformation does. All right, x plus 3. So that means right 3, and then down, because it's negative 11. Right 3, down 11. All right, I'm a man of few words. That's all we have to write. And then last one of the video. Draw and label the image JKLM after translating according to the rule XY arrow x minus 4y plus 2, and label the image using prime notation. So let's do this. I'm going to do it the cheaty way, but still explain it in great depth. Watch this. This is going to be so cool. All right. Actually, let me do it like this. Okay. Now I'm going to, actually I think I got, actually I can just shift this. Watch, I'm going to go 4 to left, 1, 2, 3, 4, then up 2. Boom. Alright. And then this is going to be L prime, M prime, J prime, K prime. Remember, prime notation is very important. It tells me the path I go. Alright. It tells me which one's the image, which one's the pre-image. And that's basically it. Alright, I went left 4, up 2. Alright. Now let's check on our students. I think I bored them. They fell back asleep. Alright. Anyways, that's it for this video.